Welcome to another video. Today we're going to be simplifying exponents. This video should be suitable for grade 11 and grade 12 students. So if you were given an expression like this one, like these two, and you are asked to simplify and leave your answers with positive exponents, how would you do them? It's important that you know your exponential laws before you attempt to do these questions. Some of the most famous ones are these ones. A to the power m multiplied by a to the power n is the same as a to the power of m plus n, and a to the power of m raised to n is the same as a to the power of m multiplied by n, and a multiplied by b to the power of m is the same as a to the power of b multiplied by b to the power of m, and a over b to the power of m is the same as a over b to b over b to the power m. So I'm not going to remove these for now. I'm gonna do the calculations while they are here so that you can always check how I arrived to some of my answers. So if you have, and by the way, we also have these ones where if you have something like a 1 over m to the power n, it becomes m to the power of negative n. So you have to also know this one as well. These ones are just corollaries, like extensions of these ones. Okay, so we know that. Let's look at a to the power 3 over b to the power of negative 3 and simplify it. And remember, we have to leave it with positive exponents. B to the power of negative 2 is in the denominator. When it goes to the numerator, it's going to become b to the power of positive 2. The sign is going to change. That's also one of the laws of exponents. And when a goes to the denominator, it's going to become a to the power of positive 3. What happens is that the sign changes. If it was positive, it becomes negative. If it was negative, it becomes positive. You see? So this one is rather straightforward. Now let's look at this one. How would this number 2, how would we do this one? Here we have 4a to the power of 7. First we have to look at b to the power of negative 4. b to the power of negative 4, when it goes down, it's going to become positive in the denominator, and c to the power of negative 1 is going to become positive in the denominator. We know that there's a 1 there even though it's not written. And then what happens to d to the power of negative 2 and e to the power of negative 5? d to the power of negative 2 goes up into the numerator and the sign changes to a positive, and e also goes up to the numerator and its sign changes to a positive. That's how you simplify. Let's go to the next example. Okay, in this example, number 3, we have x to the power of negative 1 plus y to the power of negative 1. The answer will simply be 1 over x plus 1 over y. But then again, we need to simplify this. So x, y, the common factor here, LCD, will be y, xy. So x goes into xy and leaves y. So y multiplied by this one here is going to be y. Y goes into xy and leaves x. X multiplied by that one there is going to be x. So that's what you will end up getting as your answer. Now let's go to this one, number 4. On number 4, you need to make sure that you write every one of your answers as a prime number base, like in its simplest possible way. 5 to the power of 2n is going to be left that way because it's already basic. It's very simple. 9 is equivalent to 3 to the power 2, so that's going to be its prime number base. And then of course we already had an exponent there, 2n minus 3. And then we also had 15. 15 is the same as 5 multiplied by 3. 5 and 3 are the prime bases of 15. And let's not forget 2n multiplied by 3 to the power of 4n minus 1. That's already simplified. So when you've done this step, you now need to, let me write it here. Do this, and then I'm gonna write the answer here. So now you have two bases. You have base 5 and base 3 only. So you're gonna have 5 here, and then 5 to the power of 2n, as you can see, is the first one. So we're gonna have 5 to the power of 2n. We also have 5 in the base, that's raised to 2n, so that's gonna be minus 2n there. We're gonna subtract it. Now we're gonna multiply it by 3 to the power of 2 multiplied by 3 to the power of 2 multiplied by 2n minus 3. This one here. We're gonna write this one here. So we know that 2 times 2n is going to be 4n, and 2 times negative 3 is going to be negative 6, right? And then we also have to account for 3, this one here, 3 to the power 2n. So we know that this is going to be 2n. We also need to account for this one as well, that 4n minus 1. So that's going to be minus, this is already clumsy, 4n minus 1. Let me write 4n minus 1 here, minus 4n minus 1. I assume you're taking notes so that you can keep up with what I'm doing, because I'm removing some of the steps now. Okay, so when you're left with this, you will now perform your basic arithmetic. 2n minus 2n is going to be 0, so we get 5 to the power 0, and then here we're going to have 3 to the power of 4n minus 6 minus 2n minus 4n plus 1. When you add all of that, you'll find that you're going to have 6, what's this? You're going to be left with negative 3. It's positive 5. So this is going to be 6. Okay, now let's look at this one again. We had 4n minus 6 minus 2n minus 4n minus 1. So we were left with, this is supposed to be 6n. This number here is supposed to be 6n, but for some reason I didn't write it as 6n. So when you do the calculation, you will arrive to an arithmetic solution of this kind, and this is going to be 3 to the power of negative 3, of course, and then that's going to be equal to 1 over 3 to the power 3. So 1 over 3 to the power 3 is 1, 3 to the power 3 is 243, so that's going to be 243. Yeah, so what you can do is to check the calculations that I did as well. Try to do the question on your own, at your own pace, so that you understand exactly what happened there. Let's go to the next one. And by the way, the part where you have to do the addition and subtraction of exponents is a much easier one. The part that I want you to master is the one where you get your prime bases. Okay, now let's go to the next one. Okay, here's another one. Go ahead and try it. Okay, so here what you need to do is you need to first multiply out everything. For example, you need to multiply 2 and n so that you get 3 to the power of 2n plus 3 to the power of 2n multiplied by 3 to the power of negative 1. So you remember you have to distribute your base amongst the exponents, and we use the rule that in general a to the power of a, let's say b plus c, a to the power of b plus c is the same as a to the power of b times by a to the power of c. So I use that idea there. So now divide by 9n. 9n is the same as 3 to the power of 2 multiplied by n. So all in all, we will end up writing it this way: 3 to the power of 2n. Now we can already see that there's a lot of things we can do to make this a lot easier. If you look on the left, we have 3 to the power of 2n. If you look on the right, we also have 3 to the power of 2n multiplied by 3 to the power of -1. So we can take out 3 to the power of 2n as a common factor. 3 to the power of 2n goes to 3 to the power of 2n once. 3 to the power of 2n goes here once and leaves 3 to the power of -1. And then we have 3 to the power of 2n here. This will cancel out, and then we'll be left with 1 plus 1 over 3. 3 to the power of -1 is the same as 1 over 3. But then 1 is also the same as 3 over 3. And we chose 2 over 3 because we want the bases to be the same. So take the base and say 3 plus 1 is equal to 4. And that's your answer. The answer is 4 over 3. That's how you would do this question. On this question, the bases are already good. They are in standard form. What we need to do now is to manipulate the exponents. So what can we do here? 2009 is the smallest exponent. This means that every other exponent here can be written in some way such that it has 2009 in it. That will then enable us to take out common factors and consequently cancel. So we know that 2012 is equal to 2009 plus 10, 11, 12 plus 3. So in the place of 2012, we're going to put this. In the place of 2010, we know that it's equal to 2009 plus 1. So we're going to put this in the place of 2010. So now let's write this again. You have 2 to the power of 2009 minus 2 to the power of 2009 plus 3 over 2 to the power of 2009 plus 1. In this way, it becomes easier to work with these large numbers. So you can see that on the left here we have 2 to the power of 2009, and on the right we also have 2 to the power of 2009. So what you can do is we can take out a common factor, 2009, 2 to the power of 2009. 2 to the power of 2009 goes into the left once and cancels. Negative. 2 to the power of 2009 goes into the right and cancels with 2 to the power of 2009, but 2 to the power of 3 is left out. 2 to the power of 3 over 2 to the power of 2009 times by 2 to the power of 1. I'm just rewriting this way. It's one of the laws of exponents. This one will cancel with this one here, and then all in all we will end up having 1 minus 2 to the power 3. 2 to the power 3 is 8, so it's 1 minus 8 over 2. 1 minus 1 minus 8 is equal to -7, and then 2 at the base is going to remain there, and that's how you do it. So if you want to master exponents, you have to practice, because there's many different types of questions they can answer in their exams. Use the textbooks. Textbooks have a lot of questions in them, and also make use of your teacher and your tutors as well. Okay, if you like my video, please leave a like, comment, and share it, and don't forget to also subscribe. Thank you.